Hey guys, it's Luca with Learning MTG, and today I'm going to do more of like a financial, like math, investing type video. I'm going to talk about making bets and how to choose the optimal size of your bets, called Optimal F. But we'll get to that later. Basically, when you're making an investment, it's kind of one way of thinking of it is like you're making a bet. Okay, so let's say for example, there's a $10 card and there's a 50% chance it goes to $14, and there's a 50% chance it goes down to $5. Okay, so one of the ways we could basically rewrite the situation is we could say there's a 50% chance that you are plus $4, and there's a 50% chance that you're minus $5. Now, one of the things you might do is you might say, okay, is this a bet that I want to take? And it turns out you only want to take bets that have positive expected value. In most situations, there are going to be some corner cases, but this does not have a positive expected value, because on average you're losing a little bit more than you're gaining. On average you're going to lose. So if you repeated this bet over and over and over, you would end up losing all your money. Now let's kind of flip the situation. Let's say that there's a 50% chance you gain 5 and there's a 50% chance you lose 4. If you kept making this bet over and over and over, you generate a ton of money. So that's kind of the very, very basics, right? When we're thinking about investments, when we're thinking about placing bets, there's different scenarios. You could have a situation where it's like, okay, 20% chance of +2 and maybe a 40% chance of +1 and like a 40% chance of minus 1.5. I don't know. You can think of all sorts of different bets. But basically we want to think about a bet, and we want to think about, first of all, do we want to take this bet or not? And that's going to be pretty simple. Some bets suck and some bets are good or are okay. And basically that's just about the expected value. You just average out, on average, what does the bet give you? If it gives you a positive amount, then it's a bet we're going to consider. It's better than breaking even, basically. And we're going to consider it against other positive bets. If it's a negative bet, then we're just going to throw it out and never use it because it's basically worthless. We're better off just not doing anything. So that's kind of straightforward. So let's talk about some more of the nuances here. Now, let's consider a bet where there's a 50% chance of +1 and a 50% chance of -1. So this is an even bet, right? If you made this bet many times, you're on average will break even. One of the things that you can prove mathematically is if you're considering a system where you've got these bets that you can make, let's say there's just one type of bet, then the optimal strategy is going to be to bet a percentage of your entire portfolio, let's say, or your entire stack of cash. So we'll come back to that. Let's say we've got a bet where you make +2 -1. 50% of the time you get +2, 50% of the time you get -1. One of the interesting questions is, okay, if this is your bet, how big do you want to place that bet, right? So if this was like buying a stock, or if it was like buying a magic card, you would say, okay, if this is your bet, how many stocks do you want to buy? How many magic cards do you want to buy? And it turns out you can prove mathematically that the amount you want to buy is going to be a percentage of your total portfolio. In other words, you don't want to choose some fixed amount. You don't want to say like, okay, I'm always going to bet 5, or I'm always going to bet 10, or I'm always going to bet 3. What you want to do is you want to bet some percentage of your total portfolio. And you can prove that mathematically. I'm not going to make that proof here, but it can be proven. So the next question is going to be like, okay, if the best strategy is to do a percentage, what is the best percentage? And this is kind of the crux of the whole situation, and this is what optimal F is. Optimal F is basically a number, F, and it tells you what percentage of your portfolio do you want to bet. So there's actually some really interesting things, kind of like a non-intuitive thing that I didn't realize until recently, which is funny because I've studied so much math and economics. So let's think about this bet, right? +1, -1, with each with 50%. If we're going to say, okay, we don't want to bet absolute amounts, we want to bet percentages of our entire portfolio, is this a break-even bet? It turns out it's not, because if this becomes, +1%, let's say -1%, because again, we're not betting fixed amounts, now we're betting percentages of our total bankroll. Let's think about what happens. When you win, you go up to 101%, and when you lose, you go down to 99%. So let's look at this in a spreadsheet. So let's say we have some starting amount. Let's say we have like $1,000. And I'm gonna say this is will be like the percent. This will be like the return, right? So let's say like 1.01, 0.99. Or technically it's not the return, but it's like what we're going to multiply by to get to our next. And one of the things you should know is that it doesn't matter if you like win the bet 3 times and then lose the bet 3 times, or win, lose, win, lose, win, lose, because these are happening multiplicatively, so it doesn't matter what order they happen in. So the fact that I'm saying, okay, we win a bet, we lose a bet, we win a bet, we lose a bet, in that order, it's not really going to affect the outcome. Okay. So let's have this equal this times this. Okay, so if we start with $1,000, we win our bet. Okay, now we're up to 1,010. And let's say this equals this times this. Oh, we lost. Okay, now we're down to 999.9. And now let's just continue down the line. Oh, we won. We're up to 109. And let's format this like this. Actually, why don't we format it with dollars? Okay, we're up to 109.90. Oh, now we're down to 999.80. Up to 109, and now we're down. Oops. And you can imagine doing this many, many times. And let's see what happens. I think I picked numbers that are like too close, but you can see we're down a little bit lower each time. We were at 999.5, now we're at 99.4. And let's see, I think I picked bad numbers because it goes so slowly. But it turns out, so now we're at 998.2, and when we win, we're only up to 1,008. It turns out that you'll actually end up completely broke if you keep doing this bet. If you keep doing this bet over and over and over, you'll end up with no money left, and that's so counterintuitive. It didn't make any sense to me at first. But the reason why is because there's an asymmetry when you're gaining to when you're losing. Okay, so a 1% win is not equal to a 1% loss. Let's try a different way. Let's try like 1.05 and 0.95. Maybe that'll go faster. So again, we're doing bets where you either go up 5% or down 5%. Okay. And you can see here how we're already down to 985. Can I do this? And now we're down to 970, and we're going to end up losing all our money. So you can see it's going faster. But let's think about plus, what if we gained 50% versus losing 50%? So when you gain 50%, you're up to 150% of your starting value. When you lose 50%, you're down 50%. But here, like, you lost half of everything. In order to get back, in order to break even, you need to go plus 200%. Or sorry, you need to go plus 100%. So it turns out that in order to undo a loss of 50%, you need a gain of 100%. And in order to, let's say you went down 90%. So now you're down to 10%. Now, in order to get back to 100%, you need a gain of 900%. So there's this weird asymmetry that happens where losses are more painful than gains on a percentage basis. So going up 1% and down 1% is not actually good, because when you lose that 1%, it actually hurts more than the gain you get out of the 1% up. So interestingly enough, you don't want to make this bet. This is a bad bet if you're doing things on a percentage basis, a break-even bet. And other bets that may be slightly positive, if you do them on an absolute basis, could be negative on a percent basis. And by percent basis, I mean you're betting a percentage of your portfolio. Okay, so now let's actually calculate optimal F. And I've never done this before, so we'll be learning together. Okay, so I'm going to use the example that's in this book. And I got this book, it's called Portfolio Management Formulas. It's a pretty cool book. I had it recommended on a reading list for books related to investing. So they have an example where you have a bet and it can either do plus 9, plus 18, plus 7, plus 1, plus 10, minus 5, minus 3, minus 17, or minus 7. So basically this is what it is. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. Is that right? 4 of them are negative, 5 of them are positive, and I think overall it is a positive thing. If we take the sum of this, it's 13, so it looks like yes, it is in fact have a positive EV. But now we want to figure out, okay, well, how much of your portfolio do you want to bet? If something's a positive EV bet, I've shown here why you don't want to make too big of a bet, right? Because if you bet the whole house, if you have a situation where the worst case scenario you lose your whole portfolio, then you're guaranteed to lose all your money, right? So for this one, the worst case bet is minus 17. So if I picked it so that, let's say my portfolio was like 170, right? I've got $170. If I buy 10 of these, so basically what I forgot to explain was that when you're choosing what percentage of your portfolio to bet in terms of optimal F, you're doing that in relation to the worst possible outcome, right? So if my whole portfolio is $170 and these are the bets, then if I make one of these bets, I'm risking 10% of my portfolio, because worst case, I lose 17. And you don't want to bet your whole stake. I wouldn't want to bet 100%. I wouldn't want to do 10 of these, because then if I'm betting 100%, eventually you'll get to the worst case scenario and you'll go to 0, and then you can't come back from 0, right? Kind of like how we were talking about, losing 90%. It's like you need 900% to get out of that hole. You actually can't get out of the hole if you go minus 100%. So I think what I was trying to get at when I started talking about that was, clearly, if you have a bet that's profitable, you don't want to make 0 of it. You don't want to bet nothing. You want to bet something, because then you have a chance to gain some of the profits from the good bet. But you don't want to bet everything, because if you bet everything, you're guaranteed to eventually lose all your money. So there's going to be some kind of sweet spot, and this is optimal F. So actually, I think the best way that I've seen in this book to calculate optimal F is to do it kind of experimentally. So let's try to do this on the fly. So I'm going to pick a value for F. Let's say like 0.1. Actually, let me put these values here. And I think what you're supposed to do is you're supposed to start with like 100 times this. So yeah, let's start with I think it's okay to start with this. Okay. So basically what we're doing is, this is telling you how much you're going to risk. So I think, oh man. For anyone who's taught in front of a class, it's always way harder to do something right in front of a trade over biggest loss. Not actually sure how I'm supposed to do this. Maybe it's supposed to be like, let's try 1 plus this. No. All I need to do equals 1 plus this times this. Let's see, I don't need, divided by 17. So basically what I'm saying is, okay, if I'm willing to risk 10% of my portfolio, then this is what the trade would look like if I got that outcome on that trade. This would be like the return, basically. So let me do that for each of these. And so basically what we're saying here is, okay, so if we start with $1,000, we get this outcome, then we'll end up with, and we're choosing this as our sizing. So we're basically saying we're willing to risk 10% of our portfolio in each trade, assuming the worst case scenario happens. Then this is what we'll get when we get that outcome. We'll go up to 1,052, and then this is what we'll get if the next one happens, and this is what we'll get if that happens, and this is what we'll get if that one happens, and so on. And basically, like I explained before, it doesn't really matter what order these happen in. We could flip around the orders if we're multiplying. So, you know, there's the property of multiplication that A times B times C is equal to A times C times B or whatever. Any order you want to change those. So basically what we're looking at is, what do we end up in the end? We ended up with 1062.41. So when we choose an f of 0.1, say f, our return is 6.241. Okay, so now we can start experimenting and try different values. And basically, one of the things that you can prove mathematically is that optimal f for any positive EV bet is going to be increasing and then go to 0. And that makes sense, right? I mean, there may be like more waves or something. You might expect that, but you know that it's going to start. Actually, it should start at 0, because if you make no bets, well, you break even. Whatever your break-even point, you're starting there, and then as you are willing to risk more and more of your portfolio, you're making more money. But then you hit a point where, you know, that asymmetry of losses and gains makes it so that you're losing more and more and more. And if you're risking, you know, the whole house, then you're definitely going to go broke. So knowing that it has this kind of shape, we can just try different things and we can kind of get closer and closer to this point. Okay. So if we choose 0.1, this is our return, 6.241%. What if we choose something like 0.5? So I'm going to put 0.5 in here. Now we actually lose. So we actually lost money here. So if we choose an f of 0.5, where we're willing to bet half of our portfolio on each trade, we actually end up with a negative return. So this looks like a negative like 4.051%. Okay, so we've gone too far, so let's try 0.4. Okay, so 0.4 is better, but it's not as good as 0.1. We end up with a 4.403% return. And I want to make sure I'm not cutting this out with my face, so let me move it up here. Okay, so let's try 0.3. Oops. Okay, so 0.3 gives us like a 8.8% return. So that's the best one so far. 8.811. Okay, let's try 0.2. That gives us an even better return. This gives us a 9.323% return. So this is the best one we've found so far. So let's try 0.25. That's even better. So 0.25 gives us a 9.539% return. And that's, in fact, the book says the optimal F for this particular bet is 0.24 or 24%. So basically, if you're given this type of bet, let's say it's a stock or magic card, where you know that these are the different outcomes, each with equal probability, you would want to bet 1/4 of your portfolio on this thing, which means you would want to say, okay, I'm going to bet the amount of my portfolio such that in the worst case scenario, basically in this -17 scenario, I lose 1/4 of my portfolio. So I think that's really the gist of the video. It's a lot of math, but it's very interesting stuff that I can tell you, having studied lots of economics in school, we never covered this concept, and it's really important in investing because I think it teaches you a few things. It teaches you kind of, okay, there's an asymmetry between positive percentages and negative percentages. And because of this asymmetry, we want to limit how much of our portfolio we're risking, right? So it's not like, oh, this is a great bet, I'm just going to bet everything I have on it. Like, no. You never want to do that. You never want to bet everything on a single bet, because if you use that strategy, you will inevitably lose all your money. So, and it's kind of counterintuitive. I can tell, I'm someone who deals with probabilities and numbers on a daily basis. Probably I have been doing so for my whole life. And there's a part of me that's like, oh, it's a great bet, let me just go all in, right? It's not really what you want to do, because in the long term it just won't work. Even in the short term it won't really work. So that's one big thing, is realizing, okay, so there's kind of like this balance where we don't want to bet too little, but we don't want to bet too much. And what is that optimal sweet spot? And yeah, in order to find that, you do need to think about optimal F, and you do need to think about, what are the different outcomes that you expect from this bet, and how are they, is it like a 5% chance of this, a 20% chance of that, and so on. And obviously you can't completely figure this out in the real world, you can't completely calculate out, but you can estimate it. And there's a lot more nuance to this as well, especially when you have like multiple bets going on at once, and are they correlated to each other, and there's all sorts of other types of diversification. But I think this is just a really core concept to understand. You want to understand that, okay, I want to make bets as a percentage of my portfolio, and B, that I want to find that optimal percentage. I hope you guys enjoyed this video. I hope it was helpful. I hope it wasn't too confusing, and I hope to see you guys in the next video.